Like,
Yes,
where did that come from?
it's a great question.
I'm late to the party, but I still don't quite understand where that came from.
Yeah, yeah.
Uh, 801 Phil's fired. Yeah, that's pretty accurate. All right, so I gotta turn this off. Mute that. All right, now let's see if I can pull up. How do I live chat? Where's my live chat on YouTube? Skip. All right, well, first off, I think we're live. I think so, Trey. I'm seeing myself delayed on YouTube, so it's happening there. And I'm looking on Discord, and we might be live on Discord. Uh-oh, join stage. Okay, I'm not going to join the stage. So for all of you that are currently on tuning in, as we go live, there's some things I've got to do apparently on my end. I got to pull out some chats. I mean, this is active. Like this, I'll say this hosting stuff, Trey, got really intense over the last month or two.
Nice, nice. We'll see how it
It's
goes.
Yeah, well, we're definitely going to see how this goes. So for everybody tuning in, it's great having you. I think so. I'm going to walk through with everybody. This is kind of how the sausage is made. You're seeing how this new revamped Storm Chaser coaching is happening. Gabe has created some amazing things. We're now live on YouTube. We're now live on Discord, and but I'm pulling up the questions that we're going to ask Trey tonight. So I'm here with Trey Greenwood. I think most of you know Trey, but because we're now on YouTube as well, Trey Greenwood, he's a meteorologist, storm chaser. He is a creator of Convective Chronicles, which is a YouTube page with just some amazing education. So if there's anybody that's going to help create Storm Chaser coaching, it is definitely Trey Greenwood. A lot of you know him already, which is awesome. But Trey, tell us a little bit about, you were talking as I figure all this out. I do want you to talk a little bit about, you said you did 4 weeks of monsoon chasing and chasing tours. Fill us in a little bit more on that.
Yeah, so I had my regular season. That was April through the end of June in the plains. And then I came out here, which I usually do after tours end, but one of our guests from the main tours, he is obsessed with lightning photography. So I told him I would take him out and do monsoon chasing for a while. He's an awesome guy, and I told him however long he wanted to do it, we'd do it. Because of course the monsoon is, if you like lightning, the monsoon's your thing. So we did basically 4 weeks of it. He flew home July 29th. So I've just it was good. It was a little bit of a weird monsoon pattern, but we got some good stuff, and he got some good lightning shots, and everybody's happy. So
And so was that individual out with you that entire time?
yep, he was.
Wow.
Yep. Thankfully, my parents live
Wow.
here in the Phoenix area where I am now, and so we were able to kind of make this the base, so I could kind of go home at night and sleep in my own bed, quote unquote. And he was just stayed down the street, so it wasn't too bad. But yeah, it was a grind because the pattern was a little weird, like I said, but we still had some good days. So
Cool. Well, so everybody, this is how we're going to do this tonight. So this is what we call office hours with Storm Chaser coaching. And what we do is we get one of our coaches. Tonight it's Professor Greenwood that has their office hours. So it's just like college. I mean, you go to college and your professor usually has 1 hour a week that sometimes it's 1 hour a month, depending on what school and professor you had. But where they say, hey, the office is open, you got questions, maybe we've got a test coming up, come on in. We'll answer your questions and help you out with that. So tonight, you get the co-creator of Storm Chaser Coaching, Trey Greenwood, is with us tonight. And I want to set the stage. So again, this is open. These live broadcasts are open to the public. So anybody can join, anybody can come in and listen and watch and all that cool stuff. But only our members actually get a chance to ask questions live. So only our members tonight are going to get a chance to ask Trey, I guess, questions they might have. Um, the rest of you certainly would love having you here. You're welcome to listen in. I'm going to jump in right now in our Discord chat and throw up there how you can become a member over there in Discord and YouTube. It's really easy. You just hit the join button and you become a member there. I am having challenges right now, just so everyone's aware. I'm having challenges seeing. Wait, wait. I can now see the chat. I wasn't seeing the chat in YouTube, so I'm seeing that now. So I am going to create a special questions chat over there in YouTube. So I'm going to pull that up. And I've got our chat pulled up. This is what's fun. This is why I've got to get I've got two screens, Trey. I probably need to get five or six.
For this, yeah.
Yeah, because I've got our questions channel of Discord pulled up on my phone. I've got the regular chat at Discord pulled up on one screen. I've got YouTube chat pulled up on the other screen, and I think we're good. Trey, I
Cool.
think I think I
Cool.
think we're good. I think
Awesome.
this Frankenstein monster behind the scenes that runs so beautifully for the rest of you that are watching and asking questions that Gabriel created. It's working. It's working. So that being said, this is office hours. This is the opportunity. You've got questions. If you're a member for Trey, go ahead and jump in. If you're on Discord, you can jump in the questions live question. What's it called? It's called now. So that changed to Ask Questions Here channel. Again, we posted it in the chat. You can go there, ask your questions of Trey there. I'm not going to look at the regular Discord chat for questions. Same thing over on YouTube. We created an actual question chat little channel over there at YouTube. If you've got questions, chasing questions, meteorology questions, where Trey is looking at getting his next tattoo. I don't know. Do you have tattoos at all?
I do not.
He doesn't. So where
I
he's
do not.
thinking of maybe if someday he gets one, where he might go get that. Any of those we'll ask any of those questions for those of you that are members. Go ahead and do that. So I'm looking over. Let's see. We've got a couple people. Kazaki's here. I'm looking at Discord right now. Radar Shark is in the house. Shark more. We got a lot of sharks. Where'd all these sharks come from? Bay Harbor Butcher. That's a little scary. Jen Shark. What is there? What's the connection to shark, Trey?
It's a great question.
Something else I'm miss. I feel like I'm late to the party. I'm always
It's a
late
great
to the
question.
party. Um, it's Gabe. Gabe is Nebraska Chaser. I see is checking in. Atlas. A lot of our members there. So yeah, if you guys got questions for Trey, go ahead and jump on in. It looks like Kazaki's in the questions channel. Looks like he might be jumping on as well. But let's talk about this. We are kind of starting to wrap up. I don't know how much you get into tropical storms, Trey. Um, I've followed you a lot, but most of it's always I'm looking at severe and
Hmm.
your education on that because that's where my focus usually is. It's not big on tropical weather, but
Hmm.
what's your stance on that? Do you get excited about the tropical season?
I do. I have chased a number of hurricanes. I enjoy it. It's not as I'm not as enthusiastic about it as severe weather. But there's nothing like being in the eye wall of a category 3, 4, or 5 and just getting whipped for a few hours. It's quite the experience. Um, so, but it looks like this season we're not going to have to worry about much of that because it's about as dead can be, and that looks to continue for a while in the Atlantic at least. The Pacific's another story, but the Atlantic we're gonna have a tough time getting a big season out of this one just because of the
What?
background pattern.
Yeah, I was gonna say, what's holding it back?
So this El Nino typically is not favorable for Atlantic hurricanes. It is favorable for Pacific hurricanes, and going into a super El Nino, perhaps likely a historic El Nino as far as strength goes, and so that's going to shut things down. It means there's a lot more wind shear in the Atlantic, drier air, a lot more dry air, which is both unfavorable for hurricane development despite the warm waters out there. So it's going to be tough to get a storm to survive past those negative points in the environment to get a big landfall here in the US or just big storms at all. There might be a couple, but it's definitely not going to be an active season. Might be one of the quieter ones we've seen for a while.
So I'll tell you what, if you pick the under on Kalshi for the number of named storms, you might be looking good this year.
Yeah, under looks good this year.
That's good. All right,
Yeah.
let's get to some questions. All right, I said Kazaki was busy typing away. It looks like he did. Kazaki says, "What kind of environmental factor most influences on whether or not a tornado becomes a long tracker versus just purely cyclical?"
That's going to be your hodograph. A lot of times, this is probably a question for Cameron. Cameron, I've talked to Cameron about this. There are some instability things. I forget what he mentioned, but your hodograph is a lot of that. I think your forever mezzo, that example that Cameron uses, that's your massive low level shear, somewhat weaker mid level shear. That tends to be a favorable setup for long trackers that really don't storms that are probably mostly your tornado cyclone and don't really have any chance of slowing down until they get interrupted by other storms or whatnot. So if you check out Cameron's article, you can see that forever meso hodograph. That's obviously mostly you'll see those in the southeast, maybe the Midwest and the plains sometimes, but that's mostly a southeast thing. And then those smaller hodographs that are looped but somewhat smaller, strong shear aloft, I think tends to be more cyclic. But there are some instability things in there as well. But that would be more of a Cameron question than one for me.
All right, so Kazaki, look on the schedule. See next time Cameron's also on here would be a good question, or drop it in the coach Q&A since you're a member. All right, Nebraska Chaser um, says, "Are there any early signs for what next season could bring? And if not, when do we start seeing the signals?"
So I did take a quick peek ahead. It's
Oh,
it's still a little early to tell because we don't know how this El Nino is going to progress into next year. Right now, we're expecting a peak sometime late in this year, around the November timeframe, and then it starts to wane a little bit. So we don't really know yet how quickly that's going to wane, if we when that peak's going to happen, and how El Nino and the overall ENSO pattern is going to progress into next season. Assuming we get an El Nino to stick around through most or not, if not all of next season, that might be a little less favorable for tornadoes overall in the U.S. There's not quite as many chances for big outbreaks necessarily. If you look at the Lee et al. 2016 paper I use in my video, my forecast videos, I believe they call it a persistent El Nino. You don't see a lot of those oranges and red colors on the map as much as you do in some of these other patterns. So it's usually less favorable. I saw something the other day that the frequency of dry line severe days tends to go down in El Nino versus La Nina as well. And we know the dry line makes up a good portion of the severe weather season. So early indications are that it may be somewhat quiet. They're, of course, just looking at ENSO. Of course, we'll see how that warm blob in the North Pacific and all that other stuff, teleconnection wise, lasts in the next season. But just based on ENSO, early indications are it may be a little on the quiet side. But again, it's too early to know for sure. We could see ENSO progress differently than expected, and that would have big implications on the season for next year. So we just don't know yet. But we'll probably start being able to narrow it down and get some model projections out through the summer, starting late this year into early next year, December, January, February, and then we can start putting together a better forecast for next season.
yeah, long-term forecasting always a challenge. Everybody wants to know, when should I take my chasecation?
Hmm.
It's August. Should I go early May? Should I go late May? I got to get tickets.
Yeah.
It's
Yeah.
not always that easy.
Yeah,
Not
this
a,
year worked out pretty well because it was pretty clear that May was going to be pretty quiet, which it was, and that the months around it, especially June, was going to be pretty good. So I had a lot of people ask me, should I do my chasecation in May or June? And I told them June, and hopefully it worked out well for them because June was pretty active and May was not. And that was you could see that coming ahead of time from the ENSO progression. And so hopefully next year we get something that's similarly clear ahead of time, so people can plan a little bit better.
yeah, it didn't work for me. Didn't work for me. So I did see a water spout, so
Nice.
that's a I
Yeah,
hadn't
there you
seen
go.
one of those
That's
before.
right.
So
Yeah.
I
Yeah.
did get one of those. All right,
Yeah.
Atlas. So this is Atlas Shark IN. I imagine Shark Indiana Atlas. And I did find out apparently Gabe was the one that started all this shark stuff.
Hmm.
Crazy, I because he's boss shark, I guess, in Discord. But I don't know. I don't that could be a rumor. Not sure. All right, Atlas says, do you think that the HRRR mesoanalysis that are coming out soon are going to be more reliable than the RAP mesoanalysis? This.
Um, Not sure what you mean by that because we're going to the RRFS. That is going to be our main model for the short range stuff. So I'm going to assume you might have meant that. But that jury's out. We've talked about how bad the current RRFS is. They are doing some updates. They have made some updates to it with a different version that's maybe a little bit better. We're just gonna have to wait and see how it plays out and learn the idiosyncrasies it has along the way. So it just remains to be seen. Hopefully it does well, and hopefully they'll be able to get it to a place that is going to be as good or if not better than the current wrap mesoanalysis that we have. But it remains to be seen. So we'll see.
Is version 2, is that the most recent, or have they passed that?
As far as I know, that is
Okay.
the quote unquote upgraded version with a different core, so the convection's not as ridiculous as it was with the RRFS-A. I would guess you'd call it if you look on Pivotal, it's the Rufus A. So yeah, we'll see. It remains to be seen.
So you can the Rufus and Rufus version 2 are on Weatherfront. For those of you
Yep,
that have the Weatherfront app or have that on your desktop. So both are there. I personally haven't used either one a whole lot. I certainly hear version 2 sounds like it's better and that version 1's not so great, but you're the meteorologist. You're the dentist, so I don't know.
we'll see. Yeah, it just remains to be seen. I hope it's good, and I'm sure they'll continue to iterate, but it just remains to be seen. So.
All right, here we go. Jen Shark says, "What was your favorite tornado that you chased this year?"
Has to be Effingham,
Mm.
Illinois, June 17th. It was a tough year for us. I'll be honest. It was not my favorite year of chasing I've had. Lots of missed targets, tough setups to chase, but we nailed Effingham, and we got really close to that with our tour group safely and successfully, which is always good. And we got an excellent intercept with that, a couple hundred yards away, and it was photogenic. So I would have to say that one for sure.
Rub it in. Rub it in, Trey. That's all I'm saying. All right. Let's see who we got here. Avianomi. Avianomi. Uh, I hate trying to pronounce some of these names, but anyway, here's the question. With this expected super El Nino, what could I expect out of the West Coast ski season and snow around the country in general?
Um, so what the El Nino typically is a wet southern half, dry northern half, especially dry in the Pacific Northwest. I know that's not welcome news for folks up there since they've had a rough time recently with fires and stuff, but I don't think it's going to get much better, especially with as strong as this El Nino is going to be. So the West in general, probably going to be pretty lacking on the precipitation, the winter precipitation. So not I wouldn't look forward too much to an active ski season up that way. But yeah, that's usually the El Nino pattern. Wet south, dry north. It looks like maybe the southeast quite wet this time. We're entering into uncharted territory with this particular El Nino. I mean, some of these model projections are just ridiculous. We're seeing anomalies, sea surface temperature anomalies in the Nino 3.4, the RONI, the new oceanic Nino index they have of over 5 degrees, which is, I mean, the most we've seen before is in the upper twos to low threes. So we're going to be a couple degrees maybe above where we've been before. So it's going to be uncharted territory. So it kind of remains to be seen, but that's just generally what happens in El Nino situations. Wet south, drier north, particularly dry in the northwest, particularly wet in the southeast.
So I'm just going to ask this next because Kazaki had a very similar question talking about El Nino. You got the conversation started. So he basically wants to know how that might affect autumn and winter season. Do you think it could cause late season severe weather in the Midwest? Talk a little bit about autumn and late season severe potential.
Yeah, so again, it depends, but I would suspect it's going to be more southward shifted. Typically, that's the case with these El Nino cases. You get some decent stuff down in the southeast. If you look at the paper by Ashton Cook, I believe he did the ENSO linkage in the cool season, so the winter, and I believe it's December, January, February, if I'm not mistaken. And he went month by month there. And El Nino certainly has less frequency overall, and it is southward shifted. So that would be my guess. Obviously, if the Gulf is warm, all bets are kind of off because you can get more robust, more unstable air masses farther north. But the jet stream might be a little bit more muted and more southward shifted. So we'll see. That would be my guess if I had to guess. It would be a lot more southern tier states, Gulf Coast states. And but it's kind of a crapshoot. We just don't know because this El Nino is going to be so much stronger than anything we've seen in the past that it may surprise us. So we'll see.
What typically, because a lot of these questions, Trey, are on both La Nina and El Nino. What typically is going on during the transition periods, and why is that kind of a big deal?
Yeah, the transition periods tend to be the sweet spot for the most active. Looking at spring, especially, that tends to be the most active is your transition seasons. Why that's the case, I'm sure it has something to do with how that impacts the jet stream. It's all interconnected, and frankly, that's maybe slightly above my head, slightly over my head. But we do know it does appear that the transition seasons are tend to be more active than if you just have a straight one single ENSO phase during a season, especially El Nino. Just a loose linkage. El Nino tends to be slower. La Nina tends to be more active, but it is those transition seasons. Like last year, we saw the transition seasons are pretty active, and we've seen a few of those kinds of years in the past few years. So we'll see. That's why it's so critical for next season. If El Nino maybe doesn't get as strong as expected, or it wanes faster than expected, and we get into a neutral or La Nina by the time we hit into late spring next year, that'd be a transition season. We might be looking at a more active season than expected. But if we stay in El Nino through the entire season, then it might be a little bit of a lower end season. But yeah, it's got to be something with the jet stream, that linkage. I'm probably the wrong person to ask for that, but that would be my guess.
So talk about ENSO, ENSO. What does that stand for, and what is that really tracking, measuring?
Yeah, so it's the El Nino Southern Oscillation. We've all heard of El Nino and La Nina. It's the waters in the equatorial Pacific. So they call it the Nino 3.4 region. So it's a region in the equatorial Pacific. So in the Pacific Ocean, right along the equator, between 120 and 170 degrees west longitude, and between 5 degrees north and south of the equator. So that if you were to make a box there, that's the region that's most useful for tracking ENSO. And you're looking at the sea surface temperature anomalies in that region. If you have warmer than normal waters there for a prolonged period of time, you're in El Nino. If you have cooler than normal waters in that region for a long time, you have La Nina. And those anomalies in the ocean, coupled to the atmosphere, changes how the jet stream reacts downstream and is able to impact our weather here in the U.S.
All right, over at YouTube, I just big shout out, little shout out to Braden Ballard. I saw you had a question. Just to let you know, questions for for our office hours are for members only. Would love for you to become a member. You can just hit the join button on YouTube if you'd like to, and then you can go to the questions chat of if you do the drop down menu right at the top of your chat, that will set you up and you can ask your questions there. But good having you on the show. Let's go to Oh gosh, here's good old Boss Shark. That was Gabe, right? Started this whole shark craziness. Just about every question we have, Trey, right now comes from someone with shark in the name.
Excellent.
But here we go. We're gonna pivot because that's what Gabe does. Boss Shark. This is for Phil and Trey. What are your favorite sharks?
That's a great question. Since I know nothing about sharks,
I
I'm
don't know
gonna
if it's
say
a
that
great question, but
no. I mean, yeah, I'm just being nice, making conversation. Because I know nothing about sharks, I would probably say the great white,
hmm,
because that's the one that I've heard of the most.
good old Jaws
Yep.
shark.
Yep.
Mine would be a reef shark,
Mm.
only because I actually saw one, swam with one when I was scuba diving with my
Hmm.
son. Where was this? This was in just off of the Bahamas, basically, is where we did that. And yeah, saw a reef shark. It was
Wow.
one. Thank God it was just one. It wasn't a
Yeah.
school of them.
Wow.
But
Had to
yeah,
get the heart rate
sounds
up a little bit.
that was kind of cool. Yeah, it
Yeah.
was interesting. It didn't get to, like, it never swam directly at me. It didn't get too
Yeah.
close. And reef sharks, I think, are pretty tame when
Yeah.
it comes to that. So
Yeah.
I felt safe. I thought we were
Good.
okay.
Yeah.
All right, Sharkvin says this question may sound stupid, but I'm bad with this knowledge. Again, the question is, how will this El Nino affect the hurricane season this and next year? Well, it really have. We talked a little bit about this year, so again, you guys can always members, you can always go back and watch these videos later as well. But is there any usually lasting effect of these, or does it just depend on how long that El Nino is in effect?
It just depends on how long it is. We don't know what's going to happen next summer. We just can't say with any certainty yet. Once we get into early next year, you have model projections that can get us out into the summer and maybe give us a possible idea. But right now, we don't have any specificity on what's going to happen next year. But we know this year it's probably going to be, I would guess, one of the drier seasons in recent memory. I think 2013 was the last one that was just completely devoid of much activity in the Atlantic, and we might be rivaling that this year, just given the unfavorability of the pattern.
Massive shout out. This is huge. This is actually the first time I've seen this, Trey, but we have over on YouTube. So again, we're now live on YouTube as well as Discord. Over on YouTube, we got a super chat.
Wow, nice.
We got a $2 super chat from, and all I can see is all I can see is all yours. So apologies, all your, but thank you for the super chat. Says love SCC. Thank you guys.
Thank you very much.
So thank you, all your B. Now I see a B, so it's all your B something. Who knows what that is? I don't know why my chat doesn't get a little bigger than that, but anyway, awesome. Again, if you're over on YouTube, there is a actual, and you're a member, you have to become a member. Just hit that join button. Over up above the chat, there's a drop down menu. You can go to questions. If you actually are a member and have questions for Trey, feel free to jump on in that and do that. So let's go back to Discord. Zacharologist is in the house and says, "What's your take on East-based El Nino effects, and how do you think that could play out?"
East-based El Nino effects. What exactly do we mean by that? Do we mean like what's going to happen in the eastern U.S.?
Th
Or
that's how I would take it, because obviously the El Nino isn't necessarily based in the East, or it's not doesn't come from the East.
yeah, I mean, you
So
can.
that's how I take it.
It's
How does
either
that affect
that.
East Coast
Yeah,
weather?
it's either that or where the warmest anomalies are setting up in the Pacific, I guess. But we'll go with the first one. So, like I said, for the upcoming fall and winter, where the hottest waters are, I'll be honest, I don't know much about that. The so you can the Nino 3.4 region is going to be your most significant region for that, as far as I understand. And that Nino 3.4 region doesn't shift. So that's what a lot of these indices are based on. The RONIs, I believe, based on that. But you can have I believe last time I checked the ocean sea surface temperature anomalies, you had that big strip of dark red extending all the way up to the South American coast. And we've talked about the El Nino Costero before, that really hot blob of water right off the coast of Peru in South America, and that can actually lead to a more active pattern down there in South America and lead to which can impact the jet stream, the subtropical jet, a little bit to its north in the U.S. But that's as far as really I know about that. As far as where the hottest waters are setting up, I just know that the Nino 3.4 region is the one I concentrate on the most because that's what most of these indices are based on. And it's going to be hot. So I don't know if it'll matter this year because everything's going to be so hot, super hot in the Pacific. So I can't give you a better answer than that. That would be much better for the somebody like Eric Webb. If you've seen him on X, he does great stuff with that, the
Hmm.
teleconnections and whatnot. But I'm not 100% sure on the positioning of the hottest waters and what that does.
All right, good resource, Eric Webb. If you go over to X, Zach did say and clarify where the
Hmm.
hottest waters are, is what he was referring to.
Hmm.
So, all right, Atlas is back, and I'm seeing in chat that is Gabe changing everybody's name and adding shark?
I think everyone's doing that on their own.
Okay.
I would think.
Hmm.
Ah,
He changed my name, all of us, including Phil and Trey. Did
excellent.
my name change too? Interesting. Well, we'll keep an eye on that. But Atlas is back and says, "Did you enjoy chasing in Illinois compared to other states?" Obviously, you talked about Effingham. Um,
I
what are
love
your thoughts
Illinois.
on Illinois?
Love Illinois. It's up there with my favorite states to chase, especially central and northern Illinois, because it's gridded. The road network is gridded, and most of them are paved. Unlike the Southern Plains, where you can get gridded roads, but a lot of times they're dirt, so the quality can be questionable. But Central and Northern Illinois, pancake flat, gridded roads, and great tornadoes, as we saw this year. So I love chasing in Illinois. I honestly sometimes wish I lived closer, so I could get some of those, late spring, early summer MCV days and whatnot. But Illinois is great. I love chasing up there. One of my favorites.
There you go. All right. GVN. What's GVN? I've seen VN. Now I see, not G, JVN. Jiven? I'm going to say Jiven. Jiven, why Gabe made you change. That's the name. JVN, why Gabe, you change. I don't know what that is. But hey, we're going to go with it. Wants to know, how do models like Nam and Rufus work?
That is above my pay grade. I do not know the ins and outs of the models. That is not my area of expertise. I had zero interest in that in school. There are a lot of smarter people than I am that do that stuff at NSSL and whatnot, but that is not my area of expertise. I could not tell you about what physics core they use or what how they model convection, but yeah, that's I'll leave it at that.
Let's talk about just a little bit because I'm kind of curious. I've never asked this question of anybody, but you've used a number of models.
Hmm.
You don't have to obviously cover every single one that's out there because there's too many and all that you've used, but maybe talk a little bit about which models you know tend to have certain extremes, pattern extremes that you've seen and you're aware of when you look at them.
So every model has their quirks. Every model has their things that they do that can lead to that impact how they portray what they're trying to portray. So we've talked about the NAM before, for example, does really well with cold air masses, cold frontal progression and whatnot. Tends to be a little bit too strong with surface lows, tends to be too strong with low level shear a lot of times, tends to overdo instability at times, and tends to be way too cool at the surface almost all the time. It tends to have too cool of surface temperatures, but it's a good model otherwise. We've talked about the Rufus. That is an awful model, at least the initial version, because it just vomits convection, way too much convection and too large of storms. They're trying to fix that with these new versions. So That is one. The HER is fickle. The HER tends to overmix, so it tends to drastically decrease the dew points in the afternoons of severe weather events way too much. Sometimes 15, 20 degrees too low of dew points compared to what actually happens. And that has, of course, drastic impacts on what kind of convection it models. HER sometimes tends to be too aggressive with supercell formation. And but sometimes it also has a problem with supercell persistence. A lot of times it kills MCSs or supercells off much earlier than is what happens in reality. So every model has their quirks that impacts what happens, but those are some of the main. The 3 kilometer NAM, yes, one of the worst ones as well. It's either no storms at all or a complete line, which we know there's that's those are two extremes, and most of the setups are in the middle of that, so pretty useless there. But yeah, those are some of the biases that these models have. You just have to know the biases when you're looking at them and account for them in your forecast.
That's good. Yeah, it's always helpful to remember that. And because isn't it true, Trey, that the typical, I don't know if typical chaser is the right word to use, but that chasers a lot of times want to use the models that look the best and will show them what they want to see. Is that accurate
That
statement?
is an accurate statement.
Okay.
I think I think a lot of people, myself included, sometimes have a tendency to wish cast. So they use the models that show what they want to see. So if the HER shows supercells, then they kind of side with the HER. Or, for example, if you are not able to chase a certain day, a big day where everyone is chasing, you're going to pick the models that don't look as good because you're not able to be there and you don't want anything, you don't want to miss anything. So yes, that is an accurate statement. Everybody is guilty of it at some point in their chasing career, which is why it's important to try your best to be as objective as possible and use your knowledge of meteorology and looking at the data first, the observed data before you look at the models. So yeah, you just have to be careful not to wish cast too much.
Easier said than done sometimes.
Yeah, definitely.
On that note, good segue to Kazaki with a great question over on Discord. Says, looking back, if you had to learn meteorology from scratch again without a university curriculum, what sequence of topics would you study to become the strongest forecaster as efficiently as possible?
It depends on your end goal. So if you just want to work in the weather service, I would start. I mean, so it's tough for me because I am biased by the order that I did the curriculum in because I did go to college and did it that way, and they've figured some stuff out, and that's a pretty good way to learn it. You learn the basics first, then you go into the equations, then you learn the synoptic stuff, the weather maps and stuff, and that's kind of the progression. If you were in a position where maybe from a storm chasing perspective, let's say you're not trying to do that as a job per se, but you just want to be the best forecaster for storm chasing. I would start off. I would focus on the synoptics, so and mesoscale stuff. I would not learn the equation stuff. At least I would not focus on it. I would. It's good to know the equations and know the equations that govern the atmosphere, but in a somewhat simplified fashion. So just knowing what the terms in each equation mean and represent, and how what happens when you change it a certain way, what that does to the overall quantity you're trying to find out, that is good to know. So I would probably start out with that, the basics, what equations govern the atmosphere, what the terms mean, and what happens when you manipulate those terms. It's always good to know that. And then I would go into the synoptics. So I would start by looking at the different levels of the atmosphere, what each of those mean, what geopotential height is, going through that, and then looking at the surface and stuff, and then the specialized severe weather stuff. So what is CAPE? What is wind shear? What impacts does that have on the environment? And then get into the nitty gritty with soundings and photographs and stuff. So the way they do it in college is good, but I think there's a focus too much focus on the equations and deriving the equations, which nobody can remember how to derive the equations, nor does anyone care how to derive the equations. What happens on a daily basis, you need to be able to forecast, depending on your situation, you need to be able to forecast where impactful weather is going to happen. And the way to do that is learning the synoptics and how fronts move, what happens in the exit region of troughs, different shapes of troughs and stuff. That's the important stuff. So I would focus heavily on that for sure.
Yeah, it's just go ahead and throw a curriculum together, Trey. You got we got some time here. You can just start putting
Sure.
some.
I've thought about doing some videos on the channel of the basic equation stuff because I know there are people out there who are interested in that or need help with that stuff. Definitely not deriving equations, but certainly like the vorticity equation. What do all the terms mean? What happens when you manipulate a certain term a certain way? What does that do to the vorticity and whatnot? Because that is what the background of all this stuff that happens. Why is the left exit region of a trough favored? Well, that comes from things like the geopotential height tendency equation, the vorticity equation, and stuff. It's all based on the equations. But the way they teach it in schools, they make you derive them, and nobody gives a crap about that stuff. Um, as long as you know what happens when you manipulate the equation, what does that do to the overall quantities and the actual weather that happens? That's important. So,
All is living in the Discord chat said Penn State never even touched any of the formulas.
just the forecasting class, that's probably because if it's just the
Probably.
forecasting class,
Yeah.
because that's a limited amount of time. So they don't have time to go into, deriving the vorticity equation. But if you're taking it in college, you have multiple semesters that you're learning. So they have time to do all the grunt
The
work of
fun
deriving the
stuff.
stupid equations.
All right, Ben Hart. Ben Hart. That's a new name. I don't recall seeing. So Ben, welcome. Welcome to the Academy. Ben says this may be a stupid question. First off, don't need to, none of you need to start your questions with this may be a stupid question, right? There's no stupid questions.
Amen.
Yeah, everybody's at a different learning level. There's no stupid questions because I ask questions too that people might think stupid. I don't know, but there's still questions I want to get answered, so I'm not going to apologize for that. So Ben, we'll take them all, brother. We'll take them all. He says, "I'd like a bit of clarification on the roles that speed and directional shear play in the supercell tornado process. My general understanding has been that speed shear is very important in the maintenance of a supercell, and that directional shear has more to do with the actual rotation of said updraft. But I've heard several times that speed shear is responsible for something like horizontal rolls of vorticity that get tilted into the vertical. Would you clear this up for me a bit on how their roles differ or work together?"
Yeah, that's about the farthest from a stupid question you can ask. So that's a great question, as a matter of fact, because there's a lot of misconceptions about this. So speed shear does work to create those horizontal convective rolls. So those horizontal tubes that are rotating at the surface that you've seen in diagrams, I'm sure. That's what the speed shear does. So the speed shear is going to allow those to start spinning. And then what happens is the supercell is going to ingest that into the updraft, and that's how the updraft itself attains rotation. And that's how you get supercells. Supercells are storms with rotating updrafts. That's where that comes from. Directional shear, it's that may be more so important. You can get tornadoes with limited directional shear and mostly speed shear. You can get tornadoes with mostly directional shear and little speed shear. Directional shear is perhaps more so important in tornadoes. You need to really see the winds changing in direction with height to get the strong low level shear that you need for tornadoes. So the speed shear is important. If you have just speed shear, you can still get supercells. If you don't have any directional shear relief and you just have speed shear, that means you're still going to have a lengthy hodograph. You're just not going to have that curvature in the low levels that we talked about a lot for significant tornado events. So speed shear does create those horizontal convective rolls. You were spot on there. And then the supercell ingests that into the updraft. And that's how the updraft itself starts rotating. And then it's kind of all from there. If there's a paper, it might be it's a very dense paper, but I believe it's Klemp 1987. the physics of tornadic thunderstorm, dynamics of tornadic thunderstorms, I think is what it's called, something of the sort. But KLEMP, actually, I can look it up, goes through all of this. Yeah, dynamics of tornadic thunderstorms is what it's called. And it goes through all of this kind of stuff in very uh, heavy detail. So I will post that in the chat there with that's the link to it. Great paper, foundational paper on that stuff, but it gives you the dynamics of tornadic thunderstorms and what different speed shear and directional shear does to supercells. But that you were right, you were spot on. Those horizontal convective rolls, that is due to speed shear.
Awesome. Great question. Shark Marole. That's what I'm going to go with. Said, just wanted to thank Trey and the other coaches for helping me be a better chaser. I've only done it a few times, but I was able to get and pick a good target in Cincinnati last Saturday. Parked myself basically right under a tornado warned circulation. No ground contact, but it felt good being able to make the storm intercept. Included a radar image of his position right under the velocity radar couplet of a storm just south of Dayton. And
Hmm.
I'm from Cincinnati, so I was very familiar with what was going on that day. Um, so yeah, so good job. That's what it's all about. Like if you can find, and again, that's it's steps. Would you agree, Trey, that it's whether you actually intercept a tornado your first few times, or you're just figuring out how to get close, right?
Yeah, you're not going to hit it out of the park on your first chase in most cases. It's going to take time to get used to it because a lot of chasing is pattern recognition and experience. So, yeah, it takes time to become a really well-versed chaser. So, yeah, it definitely comes in steps, and absorbing as much knowledge as you can in the early portion of your chasing journey is important. So, definitely happy that you're able to get on that. That's good, and practice makes perfect. So, it seems like you're doing great on those. Just keep it up, and yeah.
And kudos to our coaches like Trey. I mean, that's what it's all about is just getting that education, being able to learn, soak it in, and then go out there and put it to use. And that's what it's all about. So great job.
Yep.
Atlas in the chat said Cincinnati mentioned. Yeah, bro. She and looks like Cincinnati Reds. I see Hofbrauhaus. I see Flying Pig Marathon reference. Grater's Ice Cream. I'm imagining it's a slab of Montgomery Inn ribs and good old bowl or plate of Skyline chili three-way. It's right there. So yeah, they call that when you get spaghetti, chili, and cheese tray at Skyline Chili in
Hmm.
Cincinnati. It's called a
Yep.
three-way.
Nice. I have heard of that
Yeah,
legendary place, it seems. I've never actually been to Ohio. I need to make it
no
out there.
kidding.
Never
Okay,
been to Ohio. Yeah,
wow.
need to make it out
Okay,
there.
you gotta get out here. All right, maximum weather. What's up? Says when you're in your target area and multiple storms begin initiating at roughly the same time, what immediate environmental cues, surface observations, and trends help you decide which cell has the greatest potential and which one to pursue?
It's a tough one and not
Yeah.
the same in all cases. So some cases you might see a subtle wind shift or boundary in the vicinity of one of those storms. That might be your clue that a storm near that might latch on and become the one to chase. A lot of times you want to be looking at how the storms are progressing on radar and satellite, or if you're close enough visually. Um, Satellite's a good one using infrared satellite. We talked about it in the satellite module, I believe, about looking at those cloud tops. And if you get those, if one kind of has a more persistent area of colder cloud tops, that might be the one that's more robust and might have the best chance. Sometimes they might fluctuate between storms. One storm might have a cold area of cold cloud tops one scan, and the next scan the other one has it, and then the initial one kind of dropped a little bit. They'll oscillate, but the one that has the longest duration of those coldest cloud tops might be the one to get on. Um, Maybe one storm it has a little bit higher dew points, maybe just a couple degrees higher dew points near it versus another storm. You might need to get to that one. That might be a clue. It depends, but you're looking very closely at the near storm environment. If you're in a state that has a mesonet like Oklahoma, that's really good because that's a higher resolution data set there, so you can kind of get really in the weeds with the data and see very small scale trends and changes in the environment that might be applicable to that. But it just depends. Looking at radar, if one, it keeps splitting maybe, and the other one is not splitting so much, or the other one just doesn't have that look on radar. It kind of fluctuating in intensity, not really taking off, where the another one might be a little bit more robust. It just depends on the situation. But yeah, you're looking all of those tools that you mentioned, satellite, radar, surface observations, those are all important. And then visuals. If you see a storm that maybe looks a little soft, the updraft doesn't look quite as crisp as another one just down the line. Maybe that's a reason to leave. I don't like to leave a storm that I'm on until it gives me the absolute 100% reason to get off the storm. Like it's clearly undercut or clearly there's cold air surging way out ahead of it. Um, that would be a sign, but sometimes a storm just isn't it, and you see one down the line that is more robust. You go after that one. So it just depends on the case, but all those tools are important.
All right, we might do a little lightning round here. Looks like we've got a few more questions to get through before our hour is up. So here we go. JVN says, what websites, apps do you use to see pressure over certain regions and the other stuff?
So if you're looking for pressure, that'd be surface observations. So you would look at the surface obs. So the SPC mesoanalysis page has surface obs. You can use the UCAR site. If you just look up UCAR, UCAR surface, you'll come up with the surface page for that. If you have Weatherfront as well, Weatherfront has the ability to have surface observations on your different products there, satellite, radar, whatever. And you can read pressure from that. SPC also has the analyzed surface map. So if you go into what is it on the mesoanalysis page for that? That would be surface MSL pressure and wind. That'll show you the pressure contours there. That works. So that would be if you're looking for pressure specifically, that would be those would probably be the ones.
Very good. All right, I'm gonna quick check. Here we go. Next one. I said, I said rapid, and this is not so rapid on my end. Sorry. Parker J199. Trey's thoughts on the benefits or negatives of AI technology being used in forecasting.
I think it's good as far as models go. We've seen stuff like the GFS AI version, the European model AI version, have been put through the ringer so far and tested, and they've actually been shown to be a little bit more accurate than the regular versions of those models. So, in that regard, it's doing very well, and I think that's where the most use should come from AI and meteorology is trying to fine tune the models to be a little bit more accurate. The other stuff, we don't need to get into the Twitter drama that always comes from AI stuff. That is not good. But as far as models go, if we can use AI to improve our models, then that's always a plus. So, and we're doing that right now. So,
Hey, over on YouTube, extra weather. I see you had a question, but I did want to remind everybody that to ask questions and get those answered, we do ask that you become a member. So over on YouTube, you just hit that join button, become a member. It's like $3 a month, very cheap, and you get access to ask these questions as well, not just listen in, but be able to participate. So just heads up on that. Next question over on Discord, Jen Shark says, what areas of forecasting are you interested in since models aren't your thing? Radar, surface data?
I love the synoptic and mesoscale stuff. So, looking at troughs and how they behave, where the severe weather is within troughs, surface low pressure areas, frontal zones and stuff, outflow boundaries, all that stuff. That's the stuff I'm interested in, synoptic and mesoscale stuff. I don't care to learn what is going into the models and what physics core is in the, whatever such and such model and all that stuff and manipulating the equations. That's not my thing. It's the actual applied stuff, forecasting using the weather maps, basically.
Good segue into Kazaki's question. Are there any good videos, books, or papers you would suggest to better learn synoptic and mesoscale meteorology?
So I always go back to Tim Vasquez's stuff, weathergraphics.com, is it? Or weather, yeah, was it weathergraphics.org?
He's done a
Weathergraphics.com.
lot of books, right?
He's got a ton of books, and it's severe weather based, but there's also just regular weather forecasting books. But he does a great job of kind of distilling the difficult mathematical stuff, the equation stuff, and putting it into actual words and what it means. Like we talked about before, if you manipulate the terms of the equations a certain way, what does that do to the overall outcome? That's what he's good at doing. Doesn't have a lot of the calculus and stuff in it. It's mostly just applied stuff to weather forecasting and severe weather forecasting. So I would definitely recommend that. Weathergraphics.com is the website. I would start there, honestly.
He also the one book I did read of his was on storm chasing. So
Yep.
that was good.
Yep.
All right, JVN, do low top storms have weaker mesocyclones due to them being smaller, and do they have less fully condensed tornadoes because of that?
Not necessarily. Not necessarily. That would mesocyclone strength more so a product of the wind profile, not necessarily the thermodynamic profile, which would be a driver of the storm size. So, not necessarily. And it just depends. So you can get really strong mesocyclones in lower top storms if it's a really strongly sheared day, but maybe not quite as unstable. You only have maybe a couple joules per kilogram of instability, but you have really strong low level shear. Sometimes you'll see that in the cool season in the southeast a lot. Somewhat truncated cape profiles, but very strong low level shear. Those would have strong mesocyclones anyway. So not necessarily would be the answer to that.
Fair. I think Gabe is in the chat. Gabe, I just want you to know I'm going to ask for a raise, by the way. With all this additional work, here's the challenge, Trey. The one thing, like with the podcast, I was able to just kind of ask my questions and listen to everybody else's questions, and so I could learn. And my challenge here now is I don't get to learn as much because I'm also looking at all this stuff, queuing other things up, and I'm missing your answers, and I hate that because I love learning, and you're one of the best to learn from. All right, last question, Nebraska Shark. As one of the few people to have the chance to be out in the field with mobile radars, is there anything that really stood out to you? How do you think that sculpted your understanding with storms?
Um, just how fine scale the details are that you can see. That was great because you see so much stuff that a regular weather service radar is not going to show you because you can get the radar right up to the storm or tornado anytime you want. Whereas we're not dealing with fixed site radar, so you can see debris ejections, little fragments of the correlation coefficient, debris signature, spiraling outward like a hurricane from the main tornado debris signature. You can't see that with that kind of stuff with a fixed radar. You can see rear flank downdraft surges. Those are critical in tornado life cycle, tornado path. Sometimes you can't see those with normal radar, but you can with mobile radar. Lots of stuff like that. You can see little fine scale details in the hook, the weak echo hole, all that stuff. It really helps you understand the storms better. And because you can see all those details that you can't normally see. So it wasn't the easiest to capture that data really well because you had to forecast well and you had to execute well, and there's some restrictions with the radar that make it difficult. You can't go 75 miles an hour in that thing. So if you're out of position, good luck getting back in position. If it's windy, driving into the wind, good luck going 50 miles an hour. And of course, hail. You can't get that thing in hail. So you can't core punch a storm. If you need to go north to south in front of a storm, you can't core punch and get that $1 million plus dish in hail. So, but it was great looking at the data and capturing that data and really diving into it. That's what I did for my thesis. It was look at 4 different cases with mobile radar data and really dive into all the details there. And it really helps you learn about the different features of storms that you hear about, like rear flank downdraft surges and whatnot, and you can actually see them on radar instead of just looking at normal radar data. So it was great. I enjoyed it.
Definitely a different kind of storm chasing.
Yes. Yes.
Yeah, a little bit different.
Yeah.
The goal
For
is
sure.
not to 0 meter with a vehicle
Correct.
like that.
You want to get close, and we got close a few times, but you have to keep that in mind. You can't just do it like you're in your personal vehicle.
What's
You got to be
close?
careful.
What's close?
So we were, so before I was there, they got about, I would say, a quarter mile or less from the Sulphur tornado in 2016. Was a 1.6 mile wide. It had EF5 level winds. It was rated EF3. The Selden tornado in 2021, we probably got within half mile of it, a quarter mile of it at times, and we had an anticyclonic tornado spin up and go literally right in front of the uh,
Mm,
the truck. That was fun. So
okay.
we got pretty close, but
Yeah,
you can't zero meter. That's out of the question with that, unfortunately.
good. Ash made a good point when I said, I don't get a chance to hear all of your full answers, being focused on other things. She said, go back and watch the replay. You are
Good
so
point.
smart, Ash.
Great point.
Good point. So, um, what do you got coming up, Trey? What you got some good videos you're going to be whipping out there anytime soon on Convective Chronicles?
Yep, just the case studies mostly from this past season. Got a good number of cases to go through, starting the Enid Bremen, Oklahoma day from April 23rd. That is on the docket now, working on that. And then we'll go into a couple of the May cases and then the infamous June cases from Illinois, because it was all Illinois in June, it seemed. So we'll go through some of those days. And then that's really about it right now. Maybe some
Good.
filler videos in between, but we'll see.
Good, and everybody keep an eye on the forecast videos. Again, if SPC Outlook looks like it's probably forecasting 2% tornado possibility somewhere, Storm Chaser Coaching still whipping out the forecast videos as well, and those can be fun and entertaining at times. I do want you to know, so the next coaching session we got coming up is office hours with Cameron Nixon. So Trey was just talking about Cameron and some great questions for him. That's going to be next Monday, the 10th at 8 p.m. So be on a lookout for that. And also a shameless plug, Stormfront Freaks. We are actually bringing our podcast back out of retirement. So we haven't done our podcast since last November of 25. We're bringing everybody out of retirement to have a show with Reed Timmer, probably some folks from the upcoming documentary movie called Never Stop Chasing that's being released on the 21st of this month. You certainly can check out theaters near you that might be having that, but we're going to have Reed on that week. You can check out our YouTube channel or follow us on X for more details on that. But we're bringing the band back together for our special episode, so that should be fun. Any closing thoughts, Professor?
Nope. Thanks everybody for tuning in. Good questions tonight.
And you got great answers. I'm always impressed, Trey, when I get a chance to host with you. So I appreciate it as well personally. So thanks for everything. It was a great time, everybody. Take care. Have a great